begin with a decently tough question directly. If all the factors of n are written in ascending order, which factor will occupy the 11th position? And we'll do it for two cases, the number being 2916, the number being 432. I'm pretty sure you should know why we are doing two cases out over there. Anyway, let's get started. If you don't know, you'll realize it in some time. We'll factorize this. It's an unusual and a large enough number. Divisible by 4, divisible by 8. Let me check. 8 11s are 88. 36. 36 is not divisible by 8. So the highest power of 2 is only 4. 4 7s are 28. 1 11, that is 4 2s are 8. 36. 9. 729 is a perfect square, is a perfect cube, is hence because it's a perfect square and a perfect cube, it's also 6th power. And if you don't know that, you're far away. Your squares, cubes and so on should first be perfect in number systems, right? Anyway, so the factorized form of this is 2 raised square into 3 raised to 6, and hence the number of factors, I just write it in shorthand, is 2 plus 1 3 into 6 plus 1 7, 7 3s are 21, and I would notice that this is an odd number, 21, right? Especially when we are dealing with factors written in ascending order, then such background information plays a lot of role. Why does it play a lot of role? Now there are 21 positions, so when I write it in increasing order, I would say there are 21 positions. Now I'll identify the positions as F1 first position, the second position and so on, right up till the 21st position. Yeah, with the subscript, the factor written in 21st position, factor written in 20th position. And with 21 positions, what is so particular about the 11th position? Right, we need the 11th position, and that is where you would need a little bit of logic, that the 11th position is exactly in the middle of 21. If you take 21, 21 is an odd number, so leave 1 aside for the middle one, and then there are 20. 10 on one side, 10 on the other side, so the middle will be 11. Or else you could even do 21 plus 1, 22 by 2. 22 by 2 is 11. I leave that for you, and since this is the middle position, the factor here is going to be root of n. Root of n, that required value that we want is root n, is we have already factorized it. Now use the factorized form only. Is nothing but 2 into 3 cube, that is 27 3s are 54. So this is my answer. The factor that occupies the 11th position is 54. How is it for the second one? 432. 432 is a decently small number. We know it's not a perfect square. 400 is 20 square. 441 is 21 square. This lies somewhere in between. Anyway, so let's look all those thoughts that lie in between. It's not a perfect square. It comes about because if you have practiced well enough and you know the background of a question, factors written in ascending order, middle, then all these thoughts automatically come, right? So I'm racing ahead a little before explaining, but let me just do that. Is it divisible by 4? Yes. By 8? Yes. So 8 5s are 40, 32 will become a 54. 54 is 27 into 2. So when I factorize it, I get 2 cube and a 2 from here, that is 2 raised to 4, and 27. 27 is 3 cube. Right? So the number of factors of 432 is 4 plus 1 5, 3 plus 1 4, that is 20 factors. And if there are 20 factors which are even, by the same logic, if I put down the first factor in the first position, second factor in the second position and so on, 20th factor in the 20th position, 19th. Where does the 11th position lie? Now remember, this is 20, which is even, right? 20. So if I try to get 20 and 11 somewhere in the middle, but where is it? Oh, there are 10 on one side, 10 on the other side. There's no unique middle, right? So the middle will lie somewhere here, and we would have the factor in the 10th position, factor in the 11th. The middle is this dotted line, but there won't be a factor at that position. 10 and 10, 20. But I know that this position is numerically equal to root of 432. which we know lies between 20 and 21. Right? 20 square is 400, 21 square is 441. The part that I was saying I was racing ahead. Right? Oh, so somewhere between. So I know, so let me just say this is going to be 20 point something something. A factor in the 11th position is more than 20. Look here carefully. So I want a number more than 20 which divides it. Does 21 divide it? No, there's no 7. 22? No, there's no 11. 23 is a prime. No. 24. Does 24 divide this? Yes, 24 is 8 threes are. 8 will divide this, 3 will divide this. So 24 is going to be the first factor after 20 point something. And if you need the lower factor on the 10th position, go below the square root. 20, will 20 divide this? No, there's no 5. 19 is a prime, not 18. 18 is made up of 2 and 3 square. Will that divide? Yes, 18th will be this. And 18 into 24, if you do the product, you have to get 432. 18 fours are 72, 2 7 carry over, 18 twos are 36, 36 and 7 432. Hope you got that, right? So it could, but don't always say that you can answer these questions only if it is the middle one, right? Even if it's not the middle one, you can still get to the answer, right? We'll do some other position for the same question next. So let's find the factor that lies in the 18th position. 1, 8, 18th position for both of them. Now 18th I have chosen because it is the quite further ahead, right? So it will be a large enough number, right? But then we should not be worried about how large or so on. We just need to understand that the first and 21st will multiply to n, second and 20th will multiply. So let me write it out over here again. First factor lying in first and factor lying in the last, how many? 21 positions are there, will multiply to form the original number. Factor in the second position and factor in the 20th position will also multiply to form the original number. Now look here, one is increasing, the other is decreasing. If such a case happens, the sum is always a constant. One value increases by 1, the other decreases by 1. Increase by 1, decrease by 1. Right? So the sum is a constant. So what am I saying is, you could even be fast and directly say, I want the factor in the 18th position. So it will multiply with the factor in the 4th position, right? And this product will be equal to the original number, 2916. Okay. I want 18th position, but finding the first few factors are very easy. Will 1 be a factor? Yes, the first position will always be occupied by 1. Does 2 divide this? Yes. Does 3 divide this? The third position? Yes. Does 4 divide it? Yes. The factor in the 4th position is 4. So you know this is a 4. Factor in the 18th position is what I want. So factor in the 18th position will be 4. We had divided by 4. 729 is my answer, right? How about if the number is 432, we want factor in 18th position. Think again, factor in 18th position multiplied by a factor in which position is going to give us the same value, 432. There are a total of 20 factors. So the sum of these two numbers should be 21. This is logical. First, if you want the first multiplied with the 20th, the second multiplied with the 19th, right? All these, and the third multiplied with the 18th. Yeah, third and 18 are going to add up to 21. So third, which is the third factor? 1 will be the first factor, 2 will be the second factor, 3 will be the third factor, right? So third factor is the number 3 into factor in 18th position is 432. So the factor in 18th position is 3144. Am I right? 3 1 3 3 4 12. Yes, 144 is the value of the factor lying in the 18th position. So now we have done all sides. All I can say is watch out for this. Here I have said and I've explained everything in the ascending order, right? As a googly, I might also give you a question in the descending order. If it's in the descending order, rather than start with 1, 2, 3 until n, you would start with n, then n by 2, n by 3 or so on. If 2 and 3 are factors, obviously, and you are going to end up at 3, 2, 1 in that case, right? So there would be such questions in your exercises.